Throughout the labs and the explorations and the explanations that we've made and done in this course, The Chemistry of Atoms, we've made a number of assumptions based on our modern understanding of chemistry. And all these assumptions at some point will require evidence to move them from assumptions to accepted science that we can rely on. The number one assumption that we've been making is that atoms exist. Now it sounds odd nowadays to say that it's an assumption that atoms exist. It now is accepted science that they exist, and it's called the atomic theory of matter. But in the 1800s, this was not the case. This was a raging debate throughout the entire century of the 1800s, and it wasn't really accepted by the overwhelming majority of scientists until the early 20th century. And certainly as far back as the Greeks and even farther, there were philosophers who wondered about the ultimate smallest part of matter and what matter consisted of. And so there were Greek philosophers who purported this idea of the atomic theory, that there is some indivisible smallest part of matter. But the debate really didn't gain steam in a sort of a laboratory scientific realm until 1808, when John Dalton deduced or built, purported a theory, made a theory based on some experiments that he was doing, where he said, "Hey, look, everybody, I think it's true based on my science that atoms exist and there's the smallest part of nature." But again, that was the early 1800s, so the debate raged throughout the 1900s. And so that's what we're going to do right now, is sort of take a look at this debate and see if we can build up our own case for the existence of atoms. And if you remember, you have to recall, in the 1800s, it wasn't until the mid 1900s that we could actually see atoms through high-powered microscopes. So all arguments, therefore, had to be circuitous or indirect. We couldn't see atoms and say, look, they exist. So that's what we're going to do here. And one strategy that was taken was to sort of visualize chemical reactions. We know chemical reactions are a thing. And so visualize chemical reactions and assume atoms exist, and see if that assumption kind of explains how chemical reactions can occur in the realm of space and time. I mean, these reactions occur over a period of time. They're not instantaneous, and they occur in space. So can we just kind of visualize a chemical reaction taking place and build up a theory of atoms based on sort of this visualization? So that's our goal here.